Great. Good morning once more. So in our previous class, we introduced NestJs, and we discussed about, we started with the overview. We introduced NestJs. We looked at the overview, which we discussed the language, setup, and platform. Then we moved over to controllers. We looked into the technical details, the key features of NestJS controllers, and also the internal mechanism. From there, we moved over to providers, where we discussed about providers, their technical details, provider types. We talked about class providers, factory providers, value providers, and we also briefly looked at injection mechanisms. And we moved over to modules, but we did not complete it. So today, we'll be completing modules. Then we'll move over to other things. So we'll complete the NestJS introduction today. So we talked about the modules technical details, which we moved over to module types. I guess we looked at feature modules. And we were discussing shared modules. I guess we discussed shared modules. But we'll start all over again. We'll look at feature modules, shared modules, global module, and dynamic modules. Then we'll look at module resolution. So there's nothing special. We're using NestJS docs. So we head over to NestJS. Not really providers, but so we're looking at modules. So we first of all looked at our feature modules. And here we were actually following this tutorial. And if you look at our code base, oops, we created, we already have this cat module here, which we talked about controllers, providers, and exports in this module. So this is a feature module. So as you can see, we have here in our example, the cat controller and cat service are closely related and serve the same application domain. So it makes sense to group them into a feature module. So a feature module organizes code that is relevant to a specific feature, helping to maintain clear boundaries and better organization. So this is particularly important as the application or team grows and it aligns with the solid principle. So we also try to understand what solid principle is, and at least we know the basics of solid and all of that. So this is the cat module. We created the cat module. We imported cat controller and cat service into the cat module. We also exported the class cat module and we imported it in the app module here. I guess we did that. Made it available in the app module so our application can access our cat module. So now we had this application structure. I guess we discussed shared modules as well. So in Next.js, modules are singletons by default, and thus you can share the same instances of provider between multiple modules effortlessly. So we moved on to look very well into the shared modules. So every module is automatically a shared module. Once created, it can be reused by any module. So let's imagine that we want to share an instance of the cat service between several other modules. So in order to do that, we first need to export cat service provider by adding it to the modules export array. So we did this, but then we don't have any other module or any other service we want to use. Any other module we want to use this cat service in. So this is just an example. Now any module that imports cat module has access to the cat service and all of that. Okay, so we also looked at module re-exporting, where we can export our core module here. And all of that. I guess right here, what we need to care about actually is, well, first of all, let's just stop at the feature modules and shared modules. And then let's look at dependency injection in modules as stated. So here we have dependency injection. A module class can inject providers as well. So e.g. we have for configuration purposes, cat module, we have constructor private cat service, as you can see. However, classes themselves cannot be injected as providers due to circular dependency. So we also have global modules here, which I said we should skip, but then let's just look at what global modules are. So if you have to import the same set of modules everywhere, it can get tedious. Unlike in NestJs, Angular providers are registered in the global scope. So once defined, they are available everywhere. But in NestJs, however, encapsulate providers inside the module scope. So you are not able to use module providers elsewhere without first importing the encapsulating module. So when you want to provide a set of providers which should be available everywhere out of the box, e.g. the helpers, database connection, all of that, you make the module global with the global decorator. So you make this global. So once this is made global, the global decorator makes the module global scope. Global modules should be registered only once, generally by the root or core module. So in the above example, the cat service provider will be ubiquitous because modules that wish to inject the service will not need to import the cat modules in their imports array. So what this simply means is if you mark this as global, you can use it without importing it because it is now global. You can use it anywhere in your application without actually importing it. Then I also said we should skip dynamic modules, but then let's briefly look at it. For all these things, while we start building with NestJs, if we come across where we need all these things, we use this, then I'll call back your attention to where we actually explain them. I'll have dynamic modules. In Nest allow you to create modules that can be configured at runtime. So this is especially useful when you need to provide flexible, customizable modules where the providers can be created based on certain options or configurations. So you have this, you have the database module, static, for root, entities, options, and all of these providers, create database providers and all of that. So this one is a dynamic module, but this is a kind of simply an advanced stuff actually. You mostly not be needing this sometimes. So there's a hint here that says for root, method may return a dynamic module either synchronously or asynchronously. That is via a promise. And this. Okay, so you can go ahead and look at NestJs documentation and try to go over all of these things. But we'll have to move over to another topic. So moving on, we have middleware. So middleware, we look at the technical details, implementation methods. Then we have the class-based middleware and the functional middleware. Also look at, we'll highlight some advanced middleware features. Okay. Okay. So let's move over to NestJS docs and look at middleware. So a middleware is a function which is called before the route handler. So middleware functions have access to the request and response object, and the next middleware function in the application's request response cycle. So the next middleware function is commonly denoted by a variable named next. So for the technical details, so it has an interface. The next middleware has an interface, which is known as the Nest middleware interface. Nest with capital letter and middleware, M for middleware is also capital, Nest middleware for static typing. So for execution order, based on the order they are applied in configure method. So we'll shortly see how we can configure middlewares. The scope of middleware can be applied globally to specific routes or route patterns, depending on how you want to apply your middlewares. And this makes NestJS very powerful. Request cycle position also, it executes before guards, interceptors, and pipes. But we've not looked at pipes, guards, and interceptors, but we'll do that in a bit. So middlewares execute before guards, interceptors, and pipes. If you take a look at this diagram, we have client side, we have an HTTP request, we have a middleware which we execute before forwarding the request to the route handler. Now, Nest middleware are by default equivalent to Express middleware. So the following description from the official Express documentation describes the capabilities of middleware. Now we have middleware functions can perform the following tasks: execute any code, make changes to the request and the response, end the request response cycle, and all of that. Also have a warning. So Express and Fastify handle middleware differently and provide different method signatures. So you can read more about that by clicking here. So you implement Nest middleware in either a function or in a class with an injectable decorator. So the class should implement the Nest middleware interface, while the function does not have any special requirements. So they say, let's start by implementing a simple middleware feature using the class method. Okay, so we'll come over following the next project structure. What we will do here, we create a folder, we'll call it common. And in here, we create another folder called it middlewares. So what is the name of the middleware we want to create? So the name of the middleware is logger. So we'll simply call it logger middleware. Always make sure you follow NestJS naming conventions. So simply come over here, copy this, bring it over here. Great. Remember, you must mark it as injectable. Decorator that makes a class as a provider. Providers can be injected into other classes via constructor parameters, parameter injection using the NestJS built-in dependency injection system. Okay, so we'll mark it as injectable. So we have the request, we have the response, and we have the next function. So we just console on the request, and then we'll come over and say JSON stringify. We'll just say request body. Let's just say or request headers like this. And then we can also console log response. Say JC string file response. Oops, no, response JC. Like this. Okay, so now that we have our middleware, so what's next? Now, so dependency, Nest middleware fully supports dependency injection, just as with providers and controllers. They're able to inject dependencies that are available within the same module. As usual, this is done through the constructor. So applying middleware, how do we apply our middleware? There is no place for middleware in the module decorator. Instead, we set them up using the configure method of the module class. So modules that include middleware have to implement the next module interface. So let's set up the logger middleware at the app level. So we'll come over here and then we'll set up the logger middleware in here. So remember how to implement interfaces and all of that. So if you come over here in our app module, see, okay, export app module, implement nest implement. Okay, so thanks Copilot, we're getting it. We import the next module from nest.js/common. They will have the middleware consumer as well. Import it from nest.js common, and then finally we will import our logger middleware. So we'll have app middleware implement next module. We'll have the configure. So this configure now passing the consumer, middleware consumer, the consumer.apply logger middleware for route. So which route do we want to apply our middleware for all the routes? Now, if you come over here, consumer.apply logger middleware for route cat. Now, if you have other routes other than cat, by the time you specify that we want to implement this middleware for the cat route, it will only be applied to the cat route and no other. So if you come over here and we see cats, they will run on npm run start the starting compilation in watch mode, found 0 errors. Great. Now if you come over here, go to local host 3000, go to /cats. Okay, so an error here. Okay, so our request, our middleware applied and logged our request. This is our request here. JSON stringified our request. So what's happening here? So let's come over here and remove this. Let's see what we plot. Refresh. Okay, so we don't have any cats. So this is our request. So we can even say request post. By the time we save this, we'll go ahead and make refresh. Since it's a get request, then we'll see localhost 3000. So you can see that middleware is being applied to the cat route. But by the time we come over to our app module and we change this to, let's say, dogs, it should only be applied to the dog route. Then I come over here and then refresh, reload our application. If I come over here, there's nothing because we're applying this middleware only to our dog's route and not to our cat's route. Because we're applying it to only to the dog's route and not to the cat's route. But if I come over here and still change this to all routes and reload the browser now, we get it now applies to all routes, all the routes in our application. So this is basically how to apply middleware. So the middleware logic will be in here. Anything you want to do, you may want to say, okay, const host is equal to request host dot to uppercase. So the splits they return the first part dot to uppercase like this. Let's see. So logging the request, we say log post. So anything you want to do, you are just modifying the request and performing some operations just to see how you can actually use our middleware. If I come over here, now we'll see localhost in capital letters. Great. So this is basically how we can write a middleware in NestJS. So moving on, we have this, how we can apply middleware and all of this. And now, in the above example, we have set up the logger middleware for the cat route handlers that were previously defined inside the cat controller. So we may also further restrict a middleware to particularly request method by passing an object containing the route path and request method to the for route method when configuring the middleware. So in the example below, notice that we import the request method enum to reference the desired request method. So the request method enum, okay. So this request method enum, we have the get, put, patch, headers, and the rest of the request. So instead of passing this, the path is cat, but we only want to apply our middleware for request method, for the get request method. We don't want to apply our middleware to any other method. So let's say we come over here and in our app module, we remove this and make this an object. I will say path, say cat, then method, say request method, get. Let's import this from NestJS common. See where it's coming from. NestJS common. And we can change this to, now if we go back and reload our application, we see that this, we have host, local host. Now, the thing is, if we change this to, let's say, post. Now, this is an enum. So once I do this, you see all the method. Prop finds, prop patch, put, search, unlock, move, unlock, head, all, delete, get, post, and all. So once I change this to post and I save, now if I come over here and reload our application, the middleware will not be applied. We no longer see anything. The middleware is not applied because we're only applying this middleware to post request. But if I change it back to get, then we have our application working very fine. Great. NestJS is fantastic. So the configure method can be made asynchronous using async await, e.g. you can await completion of asynchronous operation inside the configure method body. And there's a warning here. When using the Express adapter, the NestJS app will register JSON and URL encoded from the package body parser by default. So this means if you want to customize a middleware via the middleware consumer, you need to turn off the global middleware by setting the body parser flag to false when creating application with Nest factory create. Okay, so we can even use route wildcard. So pattern-based route are also supported in NestJS middleware. For example, the name wildcard splat can be used as wildcard to match any combination of characters in a route. So the following example, the middleware will be executed for any route that starts with ABCD/. So any route that starts with ABCD, either slash, another sub route, slash, another sub route, this middleware will be applied to. And then the method will be all methods. There's either get, post, any method at all. We still call the middleware. So the splat is simply name of the wildcard parameter and has no special meaning. Yeah. So there's what we call splat routes. There is non-matching routes. Non-matching route as splat route. So you define a specific route to handle all those ones, like not found. So any route that is not found will fall back to the splat route. So simply, it has no specific meaning, but that's simply what it means. So we have the middleware consumer. Middleware consumer is a helper class. It provides several built-in methods to manage middleware. All of them can be simply changed in the Fluent style. The for route method can take a single string, multiple strings, a route info object, a controller. A controller class can even multiple controller classes. So this can take a string, multiple string, route info object, a controller class, and even multiple controller classes. In most cases, you will probably just pass a list of controllers separated by commas. So below is an example with a single controller. Okay. So remember what a controller is. So if you can just for route cat controller. So if we come over here and then we look at our cats, then we look at cats controller. This is for cats, so it will be applied to all these posts, get, and the rest. But it will only apply to cats controller. Okay. Excluding routes. So at times you may want to exclude certain routes from having middleware applied. So this can be easily achieved by using the exclude method. So the exclude method accepts a single string, multiple strings, a route info object to identify the route to be excluded. So you can come over here to exclude part this. So you want to apply this middleware to all your routes in all methods, but you want to exclude some specific route, or you want to exclude not route but method. So in the cat route, you want to apply this middleware to only patch, delete, and the rest of the method, but not get and post. So for the splat routes, not found route, you also want to not apply this middleware because it makes no sense to apply middleware to splat routes. That is, it actually makes no sense. So the exclude method supports wildcard parameter using the path to reject package. So you can check that out. So with the example above, logger middleware will be bound to all routes defined inside CAN's controller, except the 3 paths to the exclude method. Yeah, so this approach provides flexibility in applying or excluding middleware based on specific routes or route patterns. Oh, moving on, we have functional middleware. Yes, functional middleware. So we've seen how we can implement class-based middleware. And now we will see how we can also implement functional middleware. Okay, so let's see how we can do this. So for functional middleware, we'll just take the next Express.js approach, and everything else will be fine. Okay, so all we need to do is just copy this, bring it to application. Instead of typing the whole thing, they will see you'll see logger.func.middleware cs. Then paste this inside. So send request, send request, func. Yes. We'll bring it in our app module. So we see this is logger. We'll say apply logger like this. So we can now go ahead and reload our application. And we see request func. The only difference is we're using a function here for this middleware, which is typically like from Express.js, like Express.js middleware style. Then we can use a class, which is this is the NestJs class middleware implementation, where the request here is from Express, the response from Express, and the next is from Express as well. Then after modifying the request or doing whatever you want to do in the middleware, you will just call the next function and it proceeds to the next function or handler or class or so, anything. Okay, so this is how for the functional middleware, we just call the logger pass request, response, and next parameters. And we do whatever we want to do with the request or response or whatever it is. Then we call the next function. Great. Okay, so it's a hint here that you should consider using the simpler functional middleware alternative anytime your middleware doesn't need any dependencies. So if your middleware doesn't need any dependencies, you should just use the functional middleware. So moving on, we have multiple middlewares. So as mentioned above, in order to bind multiple middleware that are executed sequentially, simply provide a comma separated list inside the apply method. So maybe you want to apply cross origin resource sharing middleware and helmet. All you need to do is just come in here. In the apply, the app module is an apply, just pass course helmet, comma, and you're good to go. These middlewares will be applied sequentially. This one will execute first, this one second, and then this one last. This one cannot execute without executing this and this. So if your request does not get past course, it will not get to helmet. And if it does not get past helmet, it will not get to the logger middleware. So this is basically how to apply your middleware in sequence. Great. So we also have the global middleware. So if you want to bind middleware to every registered route at once, we can use a use method that is supplied by the iNest application instance. This is a global middleware. So you will just go to our main TS. And in here, we'll see app use logger. and we are good to go. So we can come over to this place and just comment this one, remove this, say logger middleware. And now if we come over here and reload our application, which will make a GET request. Now we have request func, request host, localhost. Because this one is in the root, the main file. So this will get called first, which is the request func. And then this one in the app module will get called second, which we will see request host. And then the host will be in capital letters here. Great. So middlewares are called in order in which they are applied. So moving on, I think that's all we need to know about middlewares. Actually, what I am doing here is I am not actually we defined what a middleware function is, but I'm not trying to explain what a middleware function what a middleware can do. What I'm trying to let you understand is how to use them in NestJS. So you are not beginners. I believe you already know what a middleware is and what it's capable of doing. Great. So now that we are done with middleware, we will move over to exception filters. So we'll look at the technical details, the implementation, application levels, argument host context. There's for HTTP, RPC, and WebSockets. Right. So what are even exception filters? Because I really don't know what those are. So let's move over to this. So next comes with a built-in exceptions layer, which is responsible for processing all unhandled exceptions across an application. So when an exception is not handled by your application code, it is caught by this layer, which then automatically sends an appropriate user-friendly response. Wow, it's great. It's great. So this is client side, make a request, get request. This is a filter, this is a pipe. But we really don't understand this diagram at this moment. So let's continue. So out of the box, this action is performed by a built-in global exception filter, which handles exceptions of type HTTP exception and subclasses of it. So when an exception is unrecognized, it's neither HTTP exception nor a class that inherits from HTTP exception. So the built-in exception filter generates the following default JSON response. Status code 500 message internet server error. That's if an internet server error occurs. The built-in exception filter will generate this JSON response. So we have a hint here. The global exception filter partially supports the HTTP errors library. Basically, any thrown exception containing the status code and message properties will be properly populated and sent back as a response. Okay. So we can now look at throwing standard exceptions. Now, Nest provides a built-in HTTP exception class exposed from the NestJS common package. For typical HTTP REST/GraphQL API-based applications, it's best practice to send standard HTTP response objects when certain errors and error conditions occur. So for example, in the controller, we have a find all method that's in our cat controller, and then that is a get route handler. Let's assume that this route handler throws an exception for some reason. So we can go ahead and want to throw new HTTP exception. Okay. I think let us go back to our controller. So where is it the get? Comment this. Intro new HTTP exception, which is from next common. We'll say this, say for bidding. And for the code, say 403. But Nest have all of this built in for us for bidding. So there's HTTP status and enum. So we can bring in this enum and say HTTP status from next common and say dot. Then we have found gateway timeout HTTP version not supported. I am a teapot local locked and all of this, but we'll go with forbidding. So with Express.js, there's a package known as HTTP status code. Can use that in Nodejs, Express.js, the rest. But with Nest, everything comes handy. Now, if I go back and reload application, now we see status code 403 and the message is forbidding. Awesome. So this is basically an example of an exception filter. So we use the HTTP status here. This is a HEPA enum imported from the NestJs common package. Great. Now we see this. So we're already into implementation. We indirectly also discuss the technical details. So, well, we're now looking at custom exception filters. And we'll also look at all exception filters. So let's go ahead and go back to NestJs. So the HTTP exception constructor takes two required arguments, which determines the response. So the response argument defines the JSON response body. It can be a string or an object as described below. So the status argument defined from HTTP status codes can be 500, 400, 41, 43. So by default, the JSON response contains two properties, status code and message. The default defaults to the HTTP status code provided in the status argument, a short description of the HTTP error based on the status. So to override just the message portion of the JSON, supply a string in the response argument. That's so we can do something like this. So instead of doing this, we can just copy this and move it to our application. Just paste it here. Save. And here we see cards service. Find all. Okay, so okay. This is not an async. Whether this result to please remove that. Not an async function. Okay, we'll return that, and now TypeScript is happy. So if in case an error occurs, we throw HTTP exception status, HTTP status forbidden. This is a custom message. In case you want to add, we can see error occur, something like that. Okay, error occur, yeah. So HTTP status forbidden cause error. So this is the error code. And the cause of the error is the original cause of the error is actually this error here. Great. Now, using the above, this is how the response will look. Status 403 and error. This is a custom message. In our case, we see an error code. So also have exceptions logging. By default, the exception filter does not log built-in exception like HTTP exception. So when these exceptions are thrown, they won't appear in the console. So they are treated as part of the normal application flow. So the same behavior applies to other built-in exceptions as WebSocket exception and RPC exception. So these exceptions are all inherited from the base intrinsic exception class, which is exported from the NestJs common package. This class helps differentiate between exceptions that are part of normal application operation and those that are not. So looking at custom exceptions, you can implement your own custom exception. You can export a class in the forbidden exception PS file. You can export the forbidden exception, extend HTTP exception. So you are inheriting from the HTTP exception and adding your own. Then you add the constructor, it's a super forbidden HTTP status forbidden. So instead of doing all this, when you want to call that, all you want to do is throw new forbidden exception. I don't need to pass anything because you've implemented this already. Great. So that is the use of custom exceptions. So we have built-in HTTP exceptions. We have bad requests, unauthorized, not found, forbidden. So this all inherits from the HTTP exception. So instead of doing what we did, we can just come over here and say, okay, throw new forbidden exception like this. And you can pass a description, pass this, can pass other things inside as well. So this error, you can just log into the console and you are good to go. So now TypeScript is happy. So doing all of those things, you just import the forbidden exception and remove this and this. So NestJS comes in handy with all of these things. You don't need to stress yourself going about doing all of these things. All the built-in exceptions can also provide both an error cause on all those things. So bad request exception, it pass something bad happened, cause new error, description, some error. So everything is well set for you. Message, something bad happened, error, some error description, status code 400. We have some exception filters. So why the base built-in exception filters can automatically handle many cases for you. You may want full control over the exceptions layer. For example, you may want to add logging or use a different JSON schema based on some dynamic factors. So exception filters are designed for exactly this purpose. They let you control the exact flow of control and the content of the response sent back to the client. So this is awesome. So you can come over here, exception filter, the catch, argument host, HTTP exception, and you can do all of these things. Catch, HTTP exception, this response, status, JSON, status code, timestamp, path, request URL. So for logging and other things, this comes in handy for you. Great. So we can look at the argument host and every other thing. Binding filters. You can also bind filters. You can also come here and use this decorator. Use filters, which is new HTTP exception filter. There is a create add body, create cat DTO, to throw new forbidden exception. So you are tying your new HTTP to the cat controller create method. So every other thing, you can go over the NestJS documentation, everything comes handy. If you have any questions, the server is there for us, our channel is there for us. You can just drop it there and we help ourselves out. Okay. So we've seen You can look at the argument host context. We have the HTTP, RPC, and WebSocket. So mostly we're working with the HTTP. Sometimes we work with WebSockets, but you find yourself in places where you can also work with RPC. Great. So moving on, we have pipes. And for pipes, we have technical details, built-in pipes, custom pipe implementation. So let's look at what are pipes, because I don't really know what pipes are. Coming here. So a pipe is a class annotated with the injectable decorator, which implements the pipe transform interface. So we still doesn't understand this. So pipes have two typical use cases: transformation, which transforms input data to the desired form, e.g. from string to integer, and validation evaluates input data, and if valid, simply pass it through unchanged, otherwise throw an exception. So in both cases, pipes operate on the arguments being processed by controller route handler. So Nest interposes a pipe just before a method is invoked, and the pipe receives the arguments distinct for the method and operates on them. So any transformation or validation operations takes a place at that time, after which the route handler is invoked with any potentially transformed argument. So Nest comes with a number of built-in pipes that you can use out of the box. You can also build your own custom pipes. So in this chapter, we will introduce the built-in pipes and show how to bind them to route handlers. We will then examine several custom built pipes to show how you can build one from scratch. Okay. So the built-in pipes, we have Nest comes with several pipes available out of the box. We have validation pipe, pass int pipe, pass float pipe, pass boolean pipe, pass array pipe, pass UUID, pass new pipe, default value pipe, pass file pipe, and pass date pipe. So they are exported from the NestJs common package. Let's take a look at pass in pipe, blah, 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 and all of that. Okay. So let's assume let's look at how we can bind pipes. So to use a pipe, we need to bind an instance of the pipe class to the appropriate context. So in our pass in pipe example, we want to associate the pipe with a particular handler method, route handler method. So and make sure it runs before the method is called. So we do so with following construct, which we refer to binding pipe at method parameter level. So now we want to get a cat by ID. So now at get here, remember we already, if you look at our code in the controllers, we already have cat. So slash cat, let's look at the cat service. So the cat is an array. Let's look at the DTO. Name, age, and breed. So if you want to add a cat, you add a cat with a name, age, and breed. And if you want to get a cat, slash cat to get all cats. But by the time you say find one, see, okay, at get great, find one. So come back to the cat service, find one. So we see cat throw forbidden, if cat throw not found, not found exception, it's not forbidden, not found exception. So cat dot name is equal to name. So we're searching through the array, grabbing the cat by the name, and if the cat doesn't exist, we throw a new not found exception. Now, if we come back to the controller, we have to change this by change it to name and name just for this tutorial, and then we'll import the cat from, no, we already have type, type. It was imported here. So at params, import param from NestJs common. So now we have the cat, which is the name of the cat. If you come over here and we see, okay, let's say we want to get a cat by name, cat slash bro. Now we get cat slash bro, which is forbidden. This is supposed to be forbidden. Okay, so we have an error here. Message not found, status code 404. But then the error thrown here is let's remove this. Let's just throw error. And let's reload. And now we have message not found, status code 404. Because the cat with name bro cannot be found. We don't have any cat with name bro. If you come over here, we have message not found, status code 404, and all of that. So we're trying to get a cat using the cat name. Normally we can do this using an ID, but here we want to use the cat name. And NestJs come in handy with all these decorators. So we have at param. Now at param now we're trying to extract the name parameter, which is a string. And we extract it and then we pass it to find one. Then in the service, we try to find the cat by the name in the array. And if it doesn't exist, we throw not found exception. That's great. Okay, but what exactly are we trying to do? At param ID pass int. So we're trying to make sure this is an integer. And if it is not an integer, we get an error. So at param, if you come over here and say, okay, pass int like this, and I will go ahead and reload our application. Now, the message you are seeing as validation failed, normally string is expected. Bad request, 400. This is a bad request. This is not found because we're making a bad request actually. And you can see there are no errors on the console, just the response. This is actually a bad request because what we're trying to convert a string to an integer. But if we have something like, if the string is like, if you come over here and change this to 2, this is a string. Now if I refresh 2, and now not found, because how JavaScript works is, its conversion system is, it noticed that 2 can be converted to an integer. So it converts 2 to an integer, even though we're looking at the name. So that's the reason why we no longer get that. But if you come over here and say, okay, let's look at the pipes again. Well, pass flavors for valid pipe validation pipe. Okay, so since it's a string, we don't even need the pipe. This is just for demonstration. So if you change this back to bro, hit enter, validation feed, numeric string is expected. Now if you come over here, remove this. So with those bunch of validations that you need to make before doing anything, NestJs provides everything out of the box for you. So just use pipes and all of that, and you are good to go. So moving on with all of these pipes, we've seen how we can use the pipe here to validate our ID and make sure it is an integer. So this ensures that one of the following two conditions is true. Either the parameter we receive in the find one method is a number, as expected in our call to cat service find one, or an exception is thrown before the route handler is called. So we will not get past this level. Once this is not an integer, this will throw an error and we will not even reach this level. So to ensure safety, we will not be able to even try to find one by the ID, since the ID is not a number. Now we get something like this: validation failed, invalid string expected, the error we've been getting. And it's a bad request. The status code is 400 because you cannot be using a string in form of an integer. Yeah. So the exception will prevent the body of the find one method from executing. That's great. So in the example above, we pass a class which is passed in pipe, not an instance, leaving responsibility for instantiation to the framework and enabling dependency injection. So what we're passing is actually a class, and NestJs is handling the logics for us behind the scene. And now here we have new passed in pipe, which is instantiating a class, and then we'll see error status code, HTTP still not acceptable. So if I copy this one here, and bring it over here, add this one. Okay, so if I go ahead, this is, yeah. So now we're good to go. So if I come over here and refresh, now the error message is the status code is 406 and the error is not acceptable. Great. So this is basically how to customize pipes. And now you fine tune it to your own test. So binding the other transformation pipes, all the past pipes work similarly. These pipes all work in the context of validating route parameters, query string parameters, and request body values. So for example, with a query string parameter, we have query ID, pass int, find one ID, and so. Great. So here's an example of using the UUID pipe to pass a string parameter and validate if it is actually a UUID. So UID, param UID, new as param UID. So if it is not, if it's an ID but not a UUID, you get an error. So when using pass UID pipe, you are passing UID in version 3, 4, or 5. If you only require a specific version of UID, you can pass a version in the pipe options. You have custom pipes. So as mentioned, you can build your own custom pipes, while Nest provide a robust building passing pipe and validation pipe. Let's build simple custom version of each from scratch. So you can come over here and have validation of pipe tiers. Validation pipe implement pipe transform. So transform the value, which is any value, the metadata, which is an argument metadata, and then return value. So pipe transform TR is a generic interface that must be implemented by any pipe. So the generic interface uses T to indicate the type of the input value and R to indicate the return type of the transform method. So every pipe must implement the transform method to fulfill the pipe transform interface contract. This method has two parameters, the value and metadata. So the value parameter is currently processed method is a currently processed method argument before it is received by the route handling method. And metadata is a currently processed method argument metadata. So the metadata object has these properties. There is the type, which is the body, query, param, or custom, and the meta type, which is of type unknown. The data, which is a string. So if you want to build custom pipes, you can go ahead and do that. But we've seen how we can use, for now, using the built-in pipe is a go for us. Great. You can go ahead and learn how to build custom pipes. NestJs have and if you encounter any issues, remember to drop it on the channel so we can discuss. We also have guards. Guards. So let's look at what guards are. We have guards. So a guard is a class. It's a class annotated with the injectable decorator, which implements the can activate interface. So we send a request from the client. There's a guard before it reaches the route handler. So guards have a single responsibility to determine whether a given request will be handled by the route handler or not. So depending on certain conditions like permissions, roles, ACFs, etc. present at runtime. So this is often referred to as authorization. Authorization, as in causing authentication with which it usually collaborates, has typically been handled by middleware in traditional Express applications. So middleware is a fine choice for authentication, since things like token validation and attaching properties to the request object are not strongly connected with a particular route context. So, but middleware, by its nature, is dumb. It doesn't know which handler will be executed after calling the next function. So on the other hand, guards have access to the execution context instance and thus know exactly what's going to be executed next. So they are designed much like exception filters, pipes, and interceptors to let you interpose processing logic at exactly the right point in the request/response cycle, and to do so declaratively. So this helps keeps your code try and declarative. That is, do not repeat yourself and declarative. Guards are executed after all middleware, but before any interceptor or pipe. Great. So we have the authorization guard here. So as mentioned, authorization is a great use case for guards because specific routes should be available only when the caller has sufficient permissions. So the auth guard that we build now assumes an authenticated user So it will extract and validate the token and use extracted information to determine whether the request can proceed or not. So we have injectable can activate execution context from Nest, and we have observable from RxJS. So at our guard here is injectable, which we implement can activate class, then we have can activate the context, which is the NestJS execution context. Now the request equal to context switch to http.get request. Now validate request. That is the auth guard. Now you can go ahead and use the auth guard. For now, it's just important to know that guards are like middleware, but in NestJS, they know exactly what which handler will be called next and all of those things. So they're not dumb like middleware. So when we start building stuff with NestJS, and next week we'll see how we can use all of this for authentication, authorization, and all of those stuff. Next, we have interceptors. So what are interceptors? So an interceptor is a class annotated with the injectable decorator and implements the next interceptor interface. So we have the client side send a request to be intercepted before it gets to its final destination. The response will also be intercepted if you want to. So interceptors have a set of useful capabilities which are inspired by the aspect-oriented programming technique. So they make it possible to bind extra logic before/after method execution. So transform the result returned from a function, transform the exception returned from a function, extend the basic function behavior, completely override a function depending on specific condition, e.g. for patching purposes. So the basics here. Each interceptor implements the intercept method, which takes two arguments. The first one is the execution context, and the execution context inherits from argument host. So we have the caller and all of this, blah, 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 blah. So so they say you can refer back to the exception filters for more on this topic. So exception filters, let's look at the exception filters here. These are used under the hood to just go about the exception filters and the guides. But these are interceptors. For every request, they intercept the request, and for every response, they intercept the response, adding additional context and all of those things. So we're not going to talk much about this as we don't need it for now. Moving on, we have decorators. Whoa, decorators. So what are decorators? So Nest is built around a language feature called decorators. So decorators are a well-known concept in a lot of commonly used programming languages. So, but in JavaScript world, they are still relatively new. In order to better understand how decorators work, we recommend reading this article. So, let's look at an ES 2016 decorator is an expression which returns a function and can take a target, name, and property descriptor as an argument. So you apply it by prefixing the decorator with an @ character and placing this at the very top of what you are trying to decorate. So decorators can be defined for either a class, a method, or a property. So we have decorators, we have request, response. In short form rest, we have the next, session, param, body, query, headers, IP, host params, and all of that. So we'll end this class by looking at this and trying to understand what decorators are. So exploring ECMAScript decorators, we have I will just show you an example. Oh, sure, I need this simple example. Okay, so let's quickly go ahead, stop our server. So we'll be using these decorators. I tried to introduce it in our first class, but I guess I didn't do it very well. So in this file, index.js, I just want to give you a simple example. So this function takes a it takes a target. So now the target here simply means we're targeting this class here. So let's see how we can learn this together. Okay, let's say I don't know what decorators are. So let's say we have, let's use that example, function superhero that takes a target. And we'll say this targets. Okay, let's look at the example again. Targets superhero is true and target power is flight. Okay. Targets superhero is true flight. And now we have a class. Let's say a class superhero. I remove this. Now, this is a class, no constructor, just an empty class. So let's come over here, remove this. I will say log superhero dot is superhero. Log superhero dot is superhero. Now, if you go ahead and log node index.js, it is undefined. But then let's say, okay, at superhero, like this. Now, look at this. This is a decorator at superhero. Now, if you do as this, I will come over here and say, okay. Okay, so I'm super invalid or unexpected token at superhero. This is supposed to be. Nope. It's supposed to. Okay, so I don't know why this keeps happening, but invalid or unexpected token. Mm. Okay, so normally, if you take a look at this, we're supposed to see through here, and if you say my superhero dot power, you see that you're supposed to see flight. But then, okay, so I don't know what's the cause, but this gives you an idea of what decorators are. So this maybe we should take let's see, maybe I'll prepare a short maybe 30 minutes before our next class to talk about decorators. But for now, I think it gives you a basic idea of what decorators are. I got the same error in our previous example, but decorators are just kind of functions or classes that modifies another class or method. Okay, so we've come to the end of today's class, and at least we understand the basics of NestJS and how we can basically use NestJS. So if you have any questions, you can go ahead and ask. If you have any questions, you can go ahead and ask.